Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the minimum window substring problem. So if you're watching this, just a quick heads up, this has been pre-recorded, I'm probably on holiday or something. Right, given two strings s and t of length m and n respectively, return the minimum window substring of s such that every character in t, including duplicates, is included in the window. If there is no such substring, return the empty string. The test cases will be generated such that the answer is unique. A substring is a contiguous sequence of characters within a string. So what that means is that, for example, the B, A, and C here that we need for the A, B, C, we have to count the whole B, A, N, C part. We can't skip characters and say, well, to make this work, they all exist somewhere, so we can take 3 of them. This wouldn't be a hard problem if we could cheat like that. So here we see we could take Adobe C, and that would get us A, B, and C, but this has length 6, so we're better off taking Bunk, which is only 4 letters long. Here, obviously, we take A, so we get A. Here, we have to find AA, but we can't find AA, so we're done. I'm just trying to think what the easiest way to do this is. So my immediate thought is something a bit like dynamic programming, something with a sliding window. I'm not really sure how to go about it. So for example, if I know if I start at A, I have to get all the way to the C. There's no point starting with the D or the O, so then I get to the B. I've dropped an A, so I need to extend as far as the next A. Then if I drop the B, I get to the C, and I need to extend as far as the next B, which is already contained within the bounds that I'm at, because I was looking at this. Okay. The trick is duplicates. So for example, no, I think I can work. So yeah, with the 2 A's here, if we had 2 A's in here, we'd actually need to extend all of this, which is annoying. So let's start with, what are the indices of every character? For C in S, no, for IC in enumerate S, if C in letters, if C in indices C dot append I, else indices I is C equals the singleton list I. So this tells me all the indices that I want to start with. So then what I want to do, the window, how do I want to do this? So what I'm going to do is I'm going to say save myself a little bit of work there. And the window is going to be a collections.counter t. So my window needs to start at min what I want to do here. So in this word here, the first index that I need to start at is going to be the first occurrence of A or B or C. A comes first, so it's the minimum. So it's Windows start is the minimum of indices. In fact, I0 for I in indices the item values. My keyboard is repeating a letter. Window end is the maximum of I k for li in indices dot values for this is letters L. So actually let's call this counts. So for example, if we're looking for 2 A's, now this could error. So this one here, for example, is going to fail. Try except index error, return an empty string. We know immediately that's a failure. So we now have a window start and a window end. Here we're going to start at A and we're going to find the first occurrence of a B or a C. We want the maximum of those. So B and C. So this is our first window, going from 0, 1, 2, 3, 4, 5 through to 5. So far, min valid window is window start, window end. That is our setup. Sorry, I'm not being very articulate, but I'm kind of thinking here. This is a very tricky problem. So now I know this is my first window, and the minimum valid window is therefore this so far. What we then want to do is drop this guy. Lower is window start plus 1. In fact, no, I'm going to do this slightly differently. Dropped is S of window start. That is the letter we're about to drop. Then what I want to do is I want to go to indices of the dropped thing. How do I know which index I want to go to? For I in indices dropped, if I is less than, no, if I is greater than window start, break, lower is equal to I. Hang on. Window start is I. Let's go window end is equal to the max of window start and window end. And then what I want to do for j in indices dropped, if j is greater than window end, break. I need to start with I equals none. J equals none. No, that's not gonna. That's what we want. So what this does is it moves our window. We could do this in a more clever way. But for now, it'll be fine. We'll come back to it. So what this does, basically, it says we're going to drop whatever we're looking at as our window start, and we're going to zoom. Oh, no, that's not quite what I want, is it? Offset equals I. So let's start with offset equals none. I want this. Maybe I don't want just the start and the end. Maybe I want the indices that we are checking. I care about the 0, 1, 2, 3, 5 indices. Yeah. Yeah, I think that's more what I want. Let's change all of this. I don't like it already. The window is... hang on, what did I have before? Yeah, let's go with the window is... I counts L -1 for L I in indices dot values. Window dot sort. And then what we want to do is turn this into count L minus 1. So now our window is quite different. Our window is window contains index of interest offset in indices per letter. I need to cut this out of the video. So with that, now, and I sort it to make sure that the indices are in order and the indices are unique. Oh, in fact, that's up to that. Oh gosh. What do I want to do here? I don't just want... This is a whole set, potentially. A whole list. So I really want to do IDX for IDX in range counts L. So now we have the letter repetitions as well. So if we want to do 2 A's, we're going to get 2 things that correspond to the A's that we've found. Don't know if I do want that. So the reason I'm hesitating here is I'm sort of thinking ahead a little bit. This thing is going to slide out of the window. It was saying the A is at position 0, and that was the 0th A. Do we then immediately want to look for the first A? Well, not necessarily. We want to look... Well, no, we do want to look for the first A, don't we? But the problem is that one could already be included in our thing that we're trying to find. Don't know. Let's go back to this while true loop. Dropped is a thing at S window 0 let's make that a copy of the window. An immutable copy of the window. So now we know we're going to drop the thing at the beginning of the window. So we drop the A how do we want to do this? So this is where I'm getting myself confused. If we know that this, I'm talking hypothetically, let's do this with Adobe Code Bunker and AABC. Those are my two strings. I need to end up with Bunker. That is the output I'm after. To begin with, my window is 0, 0, 0, 1, 2, 3, 0, 5, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 1. So when this drops off, how can I know that I now need to look at position 2? Okay, so if this, yeah. Dropped is now going to be A. So that means I'm looking for an A. So I go to the indices of A starting at 1. And I need to know I can just keep a set of the used indices and then start doing a scan for index in range window 0, 1 plus 1. Counts dropped. If index in used indices pass, else, that makes more explicit, so continue. So here I'm now looking at index, so I need to start at 1. My hang on, let me quickly make indices so we have it available. This is A is the list 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. B has the indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. C has the indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And counts is equal to A is 2, B is 1, C is 1. So the window gets made by taking 0 and 1 from A, pairing it with the 0 and the 1. It also takes the 0 and the 0 from B and C, 3 and 5. Right, so dropped is A. Index iterates from 1 through to 2, because that's the length of it here. So therefore is only ever equal to 1. If index is in the used, sorry, no, the length here is 3. Sorry, no, the length here is 2. Oh, that's not what I want. No, that is what I want. I want that to be counts L, but I don't want this to be counts of drop. I want this to be the len of the indices of dropped. So I want this to go from 0 to 3. Index is in 1, 2. If index equals 1, is index in the used indices? Zero, 3, 5, 10. Sorry, index is, this is if indices are dropped at that index. Indices dropped 0, 1, if 10. So this is index in 10, 13. Sorry, not 0, 1. No, sorry. Index is still in 0, 1, but that's not what we're used to checking. If index equals 10 used, if index is equal to 13, that's what we need to add on to the window. Window is equal to 0, 3, 0, 5, 0, 10, 1. And then that's when I want to add on the 13, 2 business. Window is equal to window sliced from 1. Window.append indices dropped index used. Why am I getting weird indentation? I've made a mistake somewhere here. Used indices dot add this guy. Let's call that I actually. Oh, that's what the problem is. Index is this thing. Index I index. want to do window sort again. Yes, that's correct. If window -1 0 minus window 0 0 is less than min window -1 0 minus min window 0 0 min window is equal to tuple window. This needs to be indented by what? Oops, that's finger in the wrong place on the keyboard. Tabbed in. So what's our stopping condition here? Found is false. Found gets set to true. If found is equal to, if not found, break. Then what I want to do is I want to return s sliced from min window 0 0 through to min window -1 0 plus 1. Holy moly, that thing's a bloody nightmare. Okay. Does this seem to work? So this one here, our min window is 0 0 through to. In fact, I could make this window. I could actually make this a proper thing. Window 0 0 window -1 0 plus 1. And then here, the min window is the exact same thing. I don't know if I need this sort business, but I'm going to leave it in just in case. That needs to change so slightly. So does this actually work? So the min window is 0 10 so far. I think that's yeah, that's not going to quite be the minimum. No, 11. 0 through to 11. So 0 1 2 3 4 5 6 7 8 9 10. Now that's looking good so far. So then we're now around to here with this window, and use indices is equal to 0 3 5 10 13, and min window is equal to 3 14, which doesn't help us at all. Then now we're going to get dropped is B, index in 9, if index is equal to 9. This is where we do our, it's not used, So we're going to update the window to be 5, 0, 10, 1, 13, 2. And then we want to add in our 9, 1. But this needs to be moved. So this append and sort thing, I'm sure, could be done into a proper insert, and then used indices get set into 0, 3, 5, 9, 10, 13, and min window gets set to 5, 13 because that is in fact better. And then the next thing we want to do is drop is going to be whatever's in position 5, 0, 1, 2, 3, 4, 5. C. So now index is going to come from 12. If index is equal to 12, it's not used, so the window gets slid to 9, 1, 10, 1, 12, 1, 13, 2. Used indices is now 0, 3, 5, 9, 10, 12, 13. And the min window has been updated to 9, 14. Whoops. 9, 14, misclicked. What was I doing? Yep, so that's now the smallest window. So now I want to do a dropped is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is a B again. 1. And index is, well, there's no potential indices. So we break. S from 9 to 14. 9 to 14 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Bunker. Which is what we expected. Whew. All right. Now, there's probably 1,000 typos in here already. Let's do a typo check. List index out of range. Sorry? That's better. That shouldn't have been a value. That should have been an item. That was a holdover from a previous version. Use all the example test cases. Okay. So show me what indices and counts are. So this is for the A and the AA. Zero and 2. Yeah, so this is where before we had our try and then accept index error or return the empty string. That was that edge case. We don't need that print anymore. Okay. This is a hard one. That seems to work. it's a bit of a weird sliding window, and there's so much we could do to optimize this. This slice is inefficient. We should actually be using a deck. This append and sort should really be an insert at a particular index, because this is n log n, the way it currently is, when it really should be an n. In fact, if we did it with a heap, yeah, this should be done with a heap. But then we don't know where the maximum thing is. Getting the end of it might be a bit tricky. Could maintain 2 heaps. No, that's silly. That's very silly. Let's not do that. Oh heck, let's just submit it and whoa, apparently I've tried this one before. I didn't realize I tried this one before, several years ago. Runtime error, A, B. Well, let's see what an AB does. Show me the window, the indices, and the counts. If len window is less than len of t, return empty. So the window could not be large enough. Yeah, that handles that case. Looks like I got close last time. I just got down to wrong answer. I said it's Cabe. Okay, so why is that? So I want to see the window at every step. 0, 0, 0, 1, and 3. 0, 1, 2, 3. That's fine. It also found 7, 10, 11. 5, 6, 7. Why didn't it try one further? Hang on, let me see. So every window it saw. 0, 1, 3, 3, 7, 11, 7, 10, 11. So why didn't it find 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11? Why didn't it find 9, 10, 11? All right, show me counts and indices. Oh, because it dropped the 7 out. I was looking for the next C. Hang on. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What? Why did we end up in this state? No, that seems mad to me. I don't understand how we got into this state. 0, 1, and 3. 0, 1, and 3. That makes sense. What should have happened then is that we went to 1, 3, 4, 5, 6, 7. Why didn't we go to 1, 3, 7? We were dropping the C. We then should have inserted... Oh. That's better. Jesus, I was missing the break. So what was happening was we were in fact finding it nicely, but we weren't stopping to test it, which is very infuriating. Now it'll be a speed problem. Yeah, time limit exceeded. Okay. How do I want to do this? It's a deck. But it's not quite a deck, is it? It needs to be a deck, but it needs to be one I can insert sorted. Do a tree. No, the tree's going to end up unbalanced. It would have to be an array or something fast to... Yeah, it needs to be a deck. Fast on both ends. With fast insert into the right location. What's the data structure I need for that? Probably a finger tree or something. I don't want to implement all. I don't want to do anything too complicated. Get rid of all this mess. Time limit exceeded. Usually these things don't need anything monstrously difficult. Python has a bisect library, I think. Python insert sorted. Bisect. I knew there was something. bisect.insort window index I. No need to do any of that. Oh, I should have tested that. I should have absolutely tested that. But anyway, it is what it is. Still too slow. Probably this. Yeah. Oh, poop, pop, 0. I don't know if that'll be any faster, but can't hurt. Can I avoid doing this search at all? It could be a very long way, couldn't it? Okay, let's do... Last used is an empty dictionary. For index offset in window, last used s index is offset. I do need to sort this. Excuse the motorbike. So now we don't need used indices. What we need to do is we need to do a range of last used dropped. Oh, in fact, no, we don't need to do any of this anymore. It's just that now. And then it's last used drop gets incremented. If last used dropped is greater than or equal to the length of indices of drop break, that's that condition adjusted. No, it's broken now. Yes, A, B, E. Oh, I want to make it offset +1. The reason I want to make that offset +1 is because I used the offset. I want to go to the thing after it. Now ABE again. Print counts indices last used. One of each. There are those locations. So I'm going to remove that. This one there. If last used is greater than or equal to the length of the dictionary, So no, if the thing I'm going, whatever. The idea is that if the thing I'm now going to try and index is out of range, break. The last I used was zeros. Show me the window. Now show me the window. 0, 1, 3. 1, 1, 12. No, that's wrong. Oh, not I at all. My God. I want this to be last used dropped. No, what I want to do is I want to move this up. So I now want to look at the next thing. And that's going to be... I don't even need to track that anymore. This is going to be indices of dropped of last used of dropped. That thing's a monster now. Let's see if that's doing what I want. Helps if I actually index the right thing. Dropped is not defined. What do you mean dropped is not defined? Dropped is definitely defined. Oh, I've got 3 P's in one of them. Okay, we're back working again. I don't think I need to track this part, because I never use the 1 half of this tuple. I'm always using the 0 half of the tuple. Yeah. Whoops. Oh. Balls. So that does need to keep its index. Window equals W0 for W in window. There we go. That's a little bit extra work, but it's not the end of the world. Let's disable the printing. Run it. Yeah, that's much better. Let's see if that works. That's a fair bit faster too. This, oh, amazing. We finally got there. This was a bit of a longer video. I think. How long have I been going? I don't know. It doesn't tell me. Had to resort to a little bit of Googling just to remember how bisect.insort worked. But in the end, pretty good. This is definitely a hard problem. I haven't done very well. I've apparently tried this one in the past. I have zero memory of that. I didn't succeed. So I have improved in 2 years. Or 2 years and 4 months. So that's good news. Anyway, that is it from me for today. As a reminder, I'm on holiday, so hopefully I've racked up enough of these videos to keep YouTube thinking I'm still alive. Other than that, do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.